Hello, this is Ms. Clausing. Okay, I'm going to quickly take you through multiplying and dividing rational expressions. Okay, so there's two ways we can do this. We're going to do it a way without a calculator and a way with a calculator. Okay, so let's just start with this first one. When we're multiplying fractions, remember, if we go back to Algebra 1, just side example first. If we're multiplying fractions, say we have 6 over 1 times 2 over 3, we multiply just straight across. So my 6 times 2 gives me 12, 3 times 1 gives me 3, and then I reduce the fraction. This reduces to 12 divided by 3, reduces to 4. Okay? So multiply the numerator and the denominator times each other. Then I simplify. Okay? So let's do this first one, and I'm going to show you how to do it in your calculator first, and then I'll show you how to do it without a calculator. Alright, so I'm going to multiply straight across. I have 4 times 3 times 14. Okay, so go to my calculator. And quit out of here. 4 times 3 times 14 gives me 168. So that will give me a 168 in my numerator. And then I have an x cubed in the numerator, so I'm just going to write down the x cubed. I have no other x's in the numerator I need to combine that x cubed with, so I just write down the x cubed. Now I'm going to do the denominator. I have a 4 times 21 times 4. So I go to my calculator. 4 times 21 times 4 gives you 336. So I get 336 in the denominator. And I have an x squared times x to the 5th. Remember, when I multiply variables, I add their exponents. That gives me an x to the 7th. Okay? Now, I just need to simplify this. Reduce the fraction. Now, you would not be able to do 168 divided by 336 in your head. So that's why doing it this method, you have to use a calculator. But I can go ahead and use my calculator. 168 divided by 336. 168 divided by 336. Is 0.5. If I math frac that, so I go to math and number 1, gives me 1/2. So I'm going to end up with a 1 in my numerator and a 2 in my denominator. So this will equal 1 over 2. And then the x cubed divided by x to the 7th. Remember, when I divide variables, I subtract their exponents. So 3 minus 7 will give me an negative 4. And then when it's negative, it goes down to the denominator and makes it a positive 4. Okay? So this is 1/2 x to the 4th. That's my answer when I multiply those three. And I multiply those three fractions by each other. It gives me 1 over 2x to the 4th. Or 1/2 x to the 4th. Okay, so that's that's with a calculator, right? The numbers got really big when I just multiply straight across, and I can't do that in my head. Now, let's do a division problem with a calculator, and then I'll show you how to do a multiplication and a division without a calculator. Okay, so let's go on to B. I'm going to erase this. If you need to see it again, you can back up. All right. Okay, so when I divide fractions, remember, a lot of you know the rule where you cross multiply. Well, in Algebra 2, we're not going to say we cross multiply because it gets a lot more complicated in Algebra 2. We're going to say that we multiply by the reciprocal, or we flip the second fraction. So we're going to turn in any division fraction, dividing rational expressions. So if we're dividing, we're going to change it. The little diamond there means change, or I'll just write change just so no one gets confused. Change to multiplication by multiplying by the reciprocal. Or, so that's the math term for it, multiply by the reciprocal. But really you're just flip the second fraction. Okay, fraction. A lot of abbreviating, but that's okay. Okay, so I'm going to flip this second fraction. So I have my first fraction doesn't change. It's still 6x over x cubed. But to change this division to a multiplication, I'm going to flip the second fraction. So I get x to the 5th. Again, this is called the reciprocal, over 12. All right, now I have multiplication, and what do we say when we multiply? We just multiply straight across. So I have 6 times x to the 5th in the numerator. That gives me 6x to the 5th. Over, and I have 12 in x cubed, so that gives me a 12x cubed. All right, so now I just need to reduce this fraction. So 6 divided by 12 is 1/2. I could do that in my calculator if I needed to, but it will give me a 1 over a 2. I'll leave space for my x's, so x to the 5th divided by x cubed, I subtract my exponent, so I have 5 minus 3, which equals a 2, so that means I have an x squared. Okay, so I have 1/2 x squared, and that's D. All right, so let's move on. We're going to skip C, actually, and let's go to D here. All right, D we'll do by hand. We're going to do this without just multiplying straight across. We're going to, so let's go to D. Now, everyone can agree this 8y, whenever I have, say I have 6x, I could rewrite this as 6x over 1, right? Well, that is what allows me to say this is actually 8y over 1. So, remember when we're dividing, we first want to turn it into a multiplication problem, so I'm going to multiply by my reciprocal or flip my second fraction. So I'm going to change this division to multiplication. To do that, I flip the second fraction, so it's going to be a 1 over 8y now. And my first fraction doesn't change, so I have 6y to the 5th over 5. All right, so we have been up to now just multiplying straight across. But sometimes that gives us really large numbers, like an A, and then we have to use a calculator to simplify that fraction. Well, we can, while the numbers are still small, and before we multiply straight across, we can reduce the numbers before we multiply across. So, to do that, I'm going to look at my numerator and look at my denominator. I'm going to find numbers that are the same, and basically I'm going to look at my numbers and see if any of them cancel out. So I'm going to look at this 16 and this 8. I know that 16 divided by 8 is an easy math to do in my head. 16 divided by 8 leaves me with a 2. Okay, 16 divided by 8 is 2, so I have a 2 in my numerator now. My 16 and my 8 went away. They cancel out to a 2. All right, so let's see. Is there any other easy math I can do in my head? 2 divided by 5, it doesn't really do anything for me, so I'm not going to go ahead and simplify that. This 1 isn't going to hurt me because I'm just going to multiply by 1, so it's not going to change anything. And I have this y to the 5th and this y to the 1st. So I have a y to the 5th in the numerator and a y to the 1st in the denominator. So it's really not going to help me a whole lot to simplify those right away, but I can. So y to the 5th and y to the 1st, when I simplify them, I subtract their exponents, so I have a 1 here. So 5 minus 1 is going to leave me with a y, this divided by this, or y 5th divided by y to the 1st is going to leave me with a y to the 4th, okay, when I simplify those. So that'll leave me with a y to the 4th in the numerator. Alright, so once I do that, and I've simplified everything I can by hand, I'm going to now go ahead and multiply across. So in my numerator, I have a 2 right here, and a y to the 4th, and a 1. So 2 times 1 times y to the 4th will give me a 2y to the 4th, divided by, in the numerator, all I'm left with is a 5, so I just write down the 5, okay? And that's all I do there. So it's easy when you can kind of notice you have numbers that divide evenly and you can just do a mental math in your head. You can simplify your fractions before you multiply across and cancel things out, so that way you don't have to use a calculator later on. Okay, so let's go to E. All right, I'm going to erase some of D and E. All right, E, let's just change this so it looks how you're used to seeing division problems. Like in D, we're used to seeing it with a little division sign right here, right? I can rewrite this like that. So I have 18x cubed over 7 divided by 15x to the 4th over 14. You won't have to keep doing this once you've practiced this enough and you can start to recognize how the how you solve these, but to begin with, we'll go through all the steps. So I'm going to change this into something that's a little more easy for me to recognize what I'm doing. All right, I'm dividing. I want to change it to multiplication before then I can just multiply straight across. So change this to multiplication. To do that, I flip the second fraction or multiply by the reciprocal. So I have now 14 in my numerator and 15x to the fourth in my denominator. And then over here, I still have my 18x cubed divided by 7. All right, so if I were to multiply these straight across, it would give me some really large numbers. I'd have to use my calculator to reduce the fraction. Alternatively, I can look and notice that I can see some easy mental math that I can do to reduce this before I multiply across. So I see I have a 14 in the numerator here and a 7 in the numerator here. I know 14 divided by 7 is 2, so I know I can cancel those out, and it leaves me with a 2 in my numerator. Okay. I also, let's see if there's anything else. I have this x cubed right here and this x to the fourth right here. I know when I divide, I subtract my exponents, so I have 3 minus 4 equals a negative 1. So that means I'm going to end up with an x to the first in my denominator. If it was a positive 1, I'd have an x to the first in my numerator. Okay. Let's see, anything else? Not really. The 15 and 18 don't really divide evenly for me. This 2, it doesn't really divide evenly out of anything. So I'm going to go ahead and write down what's left over. So in my numerator, I have this 2 right here. So I'm going to go ahead and write down my 2. I'm multiplying it by the 18 that I have right here left over. So times 18. And everything else in the numerator canceled out. Divide by, the only things left in my denominator are this 15, and I multiply it by what else is left over, which is this x to the first right here. Okay? All right, so let's go ahead and just solve these mental math. So 2 times 18 is 2 times 18 is 36. So this equals 36 over 15 times x to the first, which I don't need to write that 1 there. Let's see. Is that right? 36, 15. Okay. Okay, so we get here, we're not quite done though, because 36 and 15 can be reduced. We can either do this in our calculator, or we can know how to reduce by mental math. I know that 36 and 15 are both divisible by 3. If they're both divisible by the same number, I can take that number out and it just kind of goes away. What happens is, if you want to think about it, if I divide 36 by 3, I end up with 3 times 12, because 3 times 12, I'm just rewriting 36, and 3 times 5 times x, right? Just rewriting the 15. And whenever I have anything dividing by itself, it goes away. So you don't really need to do that step where you cross out the 3s. You can just reduce your fraction the way you know how to reduce fractions. But just to kind of show you exactly what's going on here, which leaves me with a 12 fifths 12 over 5x. Okay, so this is our most simplified form. Okay. Okay, so let's go back up and move on to the next section. So example 2 here. Erase this. Okay, example 2. Now, like I just said, when I have anything divided by itself, it cancels out. So when I'm simplifying fractions, all I'm doing is I'm looking where I have the same factor in the numerator as I do in the denominator. So I see an a here. I have an x minus 2 and an x minus 2. They cancel out to 1. 1 basically means they go away. That leaves me with an x plus 6 in my numerator divided by my x plus 4 times my x minus 5. That's all we're doing there. Okay? So you're just simplifying it as much as you can. Okay, then let's go into B. B. Remember I multiply, really what ends up happening is I end up just x minus 3, I multiply straight across. So I have x minus 3, 2x plus 1, times x plus 5. All in my numerator, I'm multiplying straight across here. And then I get 4x times x plus 5 times x plus 3 times 2x plus 1, multiplying straight across. Okay? So now I'm looking for things that cancel my numerator and denominator. Now, if you notice, I really didn't change anything from this step down to this step. I just got rid of the little multiplication sign in the middle. You don't have to do that. You can just, if you recognize that this is what's going on, you can just look at your multiplication in the step 1 up here in step 1, and just start crossing things off. So I have an x plus 5 here and an x plus 5 here, so they both cross off. I have a 2x plus 1 here and a 2x plus 1 here, so they both cross off and cancel out to 1. Alright, and that's it. So now I'm going to just write down what's left over. I have an x minus 3 in the numerator. And in the denominator, I have this 4x left over, this 4x, and this x plus 3. Don't try to cancel that with the x minus 3. They're not exactly the same. They don't cancel, okay? So that's all you do there. All right, last one, C, when I'm dividing. Remember, when we divide, we first want to change this to a multiplication problem. So I'm going to multiply by my reciprocal or flip my second fraction. So I'm going to end up with a 3x plus 2 in the numerator times an x minus 8 divided by my 4x times x plus 1. And then my first fraction doesn't change, so I have 4x minus 3 times x plus 1 over x minus 8. Alright, so now I'm multiplying. Remember, here I went through this step here and I showed you why we're allowed to not even really, we don't have to multiply across because really it doesn't change anything. I can just look at it straight across and not have to rewrite it. So I'm just going to do that. I'm going to look in my numerators and my denominators, find any factors that are the same. So I have, let's see, I have an x plus 1 right here and an x plus 1 right here. So those will cancel out to 1. I have an x minus 8 right here and another x minus 8. So those will cancel out to 1. And so that leaves me with anything else? I don't think so. So in my numerator, I'm left with this 4x minus 3 times this 3x plus 2 all over this 4x, which is left over in the denominator. Okay, so that's all I can do there. That's my answer. All right, next page. Let's see. All right, we're going to skip the next one. Well, next one's pretty easy. It just looks a little different, right? But all I'm really doing here when I have parentheses is I'm multiplying, okay? So don't let that fool you where it looks different. All I'm doing is multiplying. So I'm just going to look for where I have the same factor in the numerator and denominator and cancel them out. I have an x minus y here, an x minus y here. They cancel out. Notice I only cancel out one of the x minus y's. In the denominator, they don't both cancel. You need a partner to cancel you, okay? So, and that's it. So now I'm going to write down what's left over. In my numerator, I have this 5xy. And in the denominator, I'm left with an x minus y and an x plus y. And that's it for that one. And we're going to skip E. And I'll do it really fast. Okay. Remember, we can rewrite this, or you can just say, all right, this is my denominator. I know because it's under this middle dividing line. So I have, to change this to multiplication, all I do is I flip, or multiply by my reciprocal, the second denominator. So my first denominator in the numerator here, or my first fraction, doesn't change. So I have x over x plus 7, and to change it to multiplication, all I do is I flip this bottom fraction. So I have x plus 7 over x minus 9. Okay, so I'm going to look for things that I can cancel out because I'm multiplying. So I have an x plus 7 and an x plus 7, so those cancel to 1 and go away. So that's it. So now I'm just writing down what's left over. In the numerator, I have an x over an x minus 9 in the denominator. That's it for that one. Okay, let's go to this last piece. Simplify and then state the excluded values. Okay, we're going to do just a few of these. So let's do B first. So B, it's a dividing, I'm dividing. So to change it to a multiplication, because I want to be able to cancel out anything I can before I look at my excluded values. So I'm going to flip the fraction here, change this to multiplication. So dividing to change to multiplication, I end up with an x squared minus 4 in my numerator, divided by an x squared minus 3x minus 4 in the denominator, and I have x minus 4 and then x minus 2. The first fraction doesn't change. Okay, to see what cancels out, though, first I need to factor wherever it can be factored. So these first numerator and denominator can't be factored, but I could break this x minus 2 out because it'll just be easier to see where I have factors. And remember, when I have x minus 2 squared, it really means I have 2 of them. So I have x minus 2 times x minus 2 over x minus 4. So I'm just going to try and break this in pieces so that way I can cancel out whatever will cancel out. Then over here I have x squared minus 4. It's a difference of squares, so I'm just going to factor that using my brain really quickly rather than my calculator. Difference of squares, so x squared, so I get an x in both. And then square root of 4 gives me a 2 and a 2. And difference of squares is always 1 plus and 1 minus. Alright, and then the denominator, again, I can factor this. We'll do it by hand. We'll do one of these in our calculator just to get practice with that as well. But so I have x squared minus 3x minus 4, and I need to factor it. So I'm going to look for what multiplies to give me a negative 4 and adds up to a negative 3. So that would be a 4 and a 1, and if I make the 4 negative, that would add up to a negative 3. Okay, negative 4 times 1 gives me my negative 4. Negative 4 plus 1 gives me my negative 3. So I'm going to end up with an x minus 4 and an x minus, plus 1. Okay, from here and here. So I factored everything out. Now I'm just going to cancel out what cancels out. So I'm looking for what is the same, what factor is the same in the numerator and denominator. I see I have an x minus 4 here and an x minus 4 here, so I'm going to cancel those out. Then I also see I have an x minus 2 here and an x minus 2 here. Cancel them out. Remember, they have to have a partner to cancel out. And that's it. So let me just rewrite this without, rewrite this a little bit cleaner. So what's left over in the numerator is just this x plus 2. And in the denominator, I'm left with an x minus 2 from here and an x plus 1 here. The only things that haven't been canceled out. Okay, and that's that. Now, my excluded values are, think of them kind of like when we found our vertical asymptotes. Okay, my excluded values are where my domain equals 0, and it's where my domain equals 0 before I cancel out any of the factors. So I need to go back to this step here and write down all my factors for my denominator. It's before I cancel anything out. So I have an x minus 2. I actually have 2 of them. When I have 2 of them, I don't need to write them both down. I have an x minus 4 from right here. Canceled out, but that's okay. I have an x plus 1. Okay. Where these equal 0 are my excluded values. So x minus 2 to solve for x gives me an x plus 2. Or x equals a plus 2. Again, this will give me an x equals a positive 4, because I'm just moving this 4 over by adding it, right? So that'll give me x equals a positive 4. And then here, this would be an x equals negative 1. So these are my excluded values. And what this is really saying is that x cannot equal any of these points, right? They're excluded. It's not valid at those points. Remember what we talked about last time? Another thing we did when we set our so we've now learned, well, let me back up a second. We've learned 3 things we can find now by setting our denominator equal to 0. When we set our denominator equal to 0, we can find vertical asymptotes. It can tell us where our domain is undefined or where our domain doesn't equal something. So remember, we'd always write that as domain does not equal something. And it also tells us what we just learned, which are our excluded values. Okay? So 3 things we can find when our denominator equals 0. All right, so that's that one. Let's see how much time we have. All right, let's do one more of these. Let's see, which one do I want to do? Let's do C, because it looks complex, but let's just fix it up a little bit. So I'm going to delete this, or I'm going to erase this, but you can always pause it, go back, or whatever if you need to keep writing it on your notes. Okay, so here in C, I have a complex fraction. That's when I have a fraction divided by another fraction. It's called a complex fraction. And I want to first turn this into a multiplication problem. So I'm going to take this bottom fraction, or the denominator, and I'm going to multiply by the reciprocal of it. So the reciprocal is I just flip it over. So I will have an a plus 2 in the numerator, divided by a 2a minus 1 is now my denominator. The top fraction here, my numerator fraction, doesn't change. So I have 4a squared minus 1 over a squared minus 4. All right. So first thing I want to do is try and simplify this. And to simplify it, I need to factor first. Okay? So before I even factor, remember part of factoring is finding my GCF. So if we're going to list out steps here for you, for those of you that like steps, we'll go through steps on this one. Step 1, let me just cross this off so we don't get confused what we're looking at here, because I'm going to use more space. All right, so steps for solving this one. First step, I need to look for a GCF. All right, so I'm going to look for a GCF in each piece. So let's start in the numerator up here. So 4a squared minus 1, no GCF, so I'm just going to write it down. 4a squared minus 1. Okay, how about down here? A squared minus 4, no GCF, so I'm just going to write it down. Okay, I'm still multiplying. All right, a plus 2, no GCF, just write it down. 2a minus 1, no GCF, just write it down. You gotta look for your GCF because the next step is I'm going to look for my factors. Remember, we always have to look for GCFs before we factor. Okay? Okay, let's finish this one up. So the next thing we're going to do is look for our factors. So we have 4a squared minus 1 in the numerator. Does that factor? Let's see. Nope, it doesn't factor. So I'm just going to write it down. 4a squared minus 1. Nope, actually it does. Sorry, brain fart. So I have, this will factor to a 2a minus 1 and a 2a plus 1. Okay, let's just do this in our calculator. Oh, this app doesn't have, I don't know that this has the app, but you can do these. Let's see if this one has it. I don't think it does. Nope, it doesn't. Okay, so you can do these in the calculator. We can go over that together. We'll go over that more together next class, but it's really just a difference of squares. Because remember, 1 is a perfect square, even though it doesn't really look like it. Okay, so then we go down to the denominator. Let's factor that one real quick. So we have a squared minus 4. Again, it's another difference of squares, so we end up with an a and an a. And 4 becomes a 2 and a 2, and it's plus or minus. All right, now let's do this other one. We have an a plus 2. That doesn't factor. It's already simplified all the way, or fully factored. And a 2a minus 1. Alright, so we factored now. Let's see our next step. For those of you that like steps, we'll do this last one. I'll do all the steps for it. We're going to cancel out whatever we can cancel out. So we have a 2a minus 1 here and a 2a minus 1 here, so I'm going to cancel those. And I have an a plus 2 here and an a plus 2 here, so I'm going to cancel them. And that's it. So what I'm left with in my numerator is a 2a plus 1 over an a minus 2. And so that's fully simplified there. All right, so let's just talk about our excluded values for a second. Remember, our excluded values are, just add another step here, but really you won't have to do this all the time. Usually this will be asked as like a separate question. but it is asked in your homework together. So excluded values, remember I just set my denominator before I cancel equal to 0. So I set my denominator before I cancel equal to 0. So that means I'm coming back up here to where I cancel. I'm going to grab my denominator factors and set them each equal to 0. So I have an a minus 2 right here. I have an a plus 2. And set these all equal to 0, and I'll end up solving. And I have a 2a minus 1. Set it equal to 0, and I'll solve. So this first a minus 2, when I solve for a, it gives me a equals a positive 2. The second one gives me an a equals a negative 2. And this last one, we'll just do this because it's a little more complicated. So I'm going to add my 1 over. Gives me a 2a equals 1. Divide both sides by 2. Gives me an a equals 1/2. Okay, so just to list them by each other. We'll do that. Alright, so these are my excluded values. Remember, excluded values, what it really is saying is that a cannot equal any of these values. Okay? For it to be a valid function, a cannot equal any of those valid values. Alright, I think that's it for the notes. I'm not going to do B or E. So yeah, sorry, it was a little longer than I was thinking, but 30 minutes still. It's 15 minutes a day of work, so not too bad. Alright, so I will see you in class.